Hello everybody. So we are going to start preparing for term 3, okay? We are going to start doing term 3 work here, okay? So I want us to start with electric circuits, okay? So electrical circuits for term 3. So I brought something here, okay? So these are the notes. So this is a list of formula that you need for electrical circuits on term 3, okay? So let us look at what is we have here, okay? So the EMF, the epsilon here, is the EMF, okay? The EMF that you need. So this is there are two equations. The EMF, which is the total voltage, or the total, the maximum energy given off, okay? So now, the epsilon here is the EMF, and then, so guys, you have to watch here that unlike the Ohm's law, the I on the EMF equation is not just any current, it's the total current of the circuit, okay? It is the total current. So you don't just use any current on the circuit here, on the equation for EMF, okay? And then now, not the small r, there is a difference here. The small r and the big R. The small r is the internal resistance of the circuit, okay? So the internal resistance will be found inside the power source. So in many cases, you will see a dotted line like this. You will see a dotted line like that, eh? So the resistance which is inside the dotted line is the internal resistance of the power source. Or, so that's the first equation. The second equation, V external is the potential difference of all the external resistors. And then V internal is the potential difference of the internal resistance of the circuit. Okay. Now, and then this is Ohm's law, the old Ohm's law that you know. Potential difference equals to the current multiplied by the resistance. Then we have Q. Q equals to I delta T, where Q is the charge. So P equals to VI. So it's V multiplied by the current. V, the potential difference multiplied by the current. And then you also have P equals to I squared multiplied by R. And then, okay, so there are three equations for power. Okay. Well, the fourth one also involves power, where energy equals to P multiplied by the time. And your time should be in seconds here. Your time is in seconds, and your time is also in seconds. Okay? The resistance is in ohms, Okay. And then it's in volts. The current is in amperes. Okay. And then the cost. Okay. This is the equation calculating cost. So you don't find this. You don't find this on the formula sheet. Okay. You don't find this on the formula sheet, but then you are required to calculate the cost sometimes, isn't it? So you should know how to calculate the cost if you are required to. Okay. And then the other thing about electric circuits is that you should know the difference between parallel and series. Okay. We should know the difference between series and parallel. So the series, you can see the resistors are connected in one after the other. Okay. Resistors are connected one after the other. And then parallel, they're connected across alongside each other. Okay. They are connected across alongside one another. So now series, they have the same current. Parallel, they have the same voltage. They have the same potential difference. Okay. So they are connected alongside each other, and here they're connected one after the other. Okay. Now the equations. Okay. Of course, now you should be careful with the equations because the equations on this side do not apply on this side. Okay. You don't calculate resistance for a series the same way you would for a parallel. So it is a fraction for a parallel and it's not a fraction for a series connection. So if it's in series, it means the resistors have the same current. Okay. If they're in parallel, the resistors have the same voltage, or you can say potential difference. Okay. Now, so it can be same current or same potential difference depending on the type of connection. Okay. Now, the voltage for a series is addition. You add all the voltages. Now the current, you add all the currents for a parallel. The current is the same here. The voltage is the same here. Okay. And then, okay, so let us do an example. Okay. Let us do an example together where we apply a list of formulae that we have here. So I have a question here from, this is a question from Limpopo, September 2024. So it's question 8. Okay. It's question 8. Now, what I like to do is, now you can see that 8.1, the first thing they want is the definition. They say define the term EMF of a battery. Okay. So the EMF, so the definition is the first thing that they want. So this is the what? The maximum energy. The maximum energy that is supplied by the battery, that is supplied by the battery per unit charge. Per unit charge passing through it. So this is the definition for EMF. Okay. Now the other questions begin from 8.2. So let us read the question. Okay. What does it say? In the circuit shown in the diagram below, the reading on the ammeter A1 is double that on the ammeter A2, and the reading on voltmeter V2 is 3 times. Okay, so A1 is double and V2 is 3 times that on V1. So V2 is here, it is 3 times that one. A1 is here and it's double A2. So what then happens here? The current will move from a positive terminal, isn't it? The current moves from the positive terminal, goes out of the circuit. It passes through A1, it passes there, and then the current becomes separate. Okay. The current becomes separate, and then it goes here. So the current becomes separate. So now the current will split into two. Now they are telling us that it is double. What that means is that the current passing here is the same as the current passing there. Okay. Now, what does that mean? Now, that means that the resistance has to be equal, right? The resistance aside has to be equal to the resistance on this branch for the two currents to be equal to each other. See, so the current is the same, meaning the resistance on this branch is the same as the resistance on that branch. So that means that R2 will be equal to R1 plus 10 ohms. Okay. Now they told us we must calculate the resistance for resistor R1. What do we know? We know that V2 is equal to 3V1. So that means that what? I R2 equals to 3, then I R1. So that means therefore we can cancel the current, isn't it? Because the two currents are equal. The current passing through R1 and R2 are the same. So we then can R2, we said that R2 is equal to, we then have 10 plus R1 being equal to 3 R1. So this means that therefore 10 equals to 2R1, because if we bring it this side, it will subtract. So it means therefore R1 will then be equal to 5 ohms. R1 will be equal to 5 ohms. We divide by 2. We divide by 2 on both sides here to remove the 2 here. Then we are left with R1, which is 5 ohms. Resistor R2. So R2, we can get it from here. So we cancel I on both sides. So we know that I R2 equals to 3 I R1. So that means that we can cancel this, and then we have R2 equal to 3 R1. So it is equal to 3 multiplied by 5 equals to 15 ohms. So now that is R2. Okay. And then they gave us more information. They give us more information. They say the reading on V2 is 9 volts. The reading on V2 here is 9 volts. Okay. If the reading on V2 9 volts, then what do we do? What can we do with that information? Then we go to 8.3 now. 8.3. So they calculate potential difference across the 10 ohm resistor. Okay, across the 10 ohm resistor, potential difference. Now, what do we know? We know that we know the voltage here, voltage. Okay, so the voltage is equal. They have the same voltage because they are. So this means that V2 will be equal to V1 plus V 10 ohms. So this means that V2 equals to V1. V1 is V2 divided by 3. Okay. Divided by 3. Then plus V 10 ohms. So therefore, 9 will be equal to 9 divided by 3 plus V 10 ohms. So therefore, V 10 ohms. Then 9 minus 3 equals to 6. The 3 comes from here. That is 9 divided by 3. Okay. So means the voltage across the 10 ohms is 6 volts. Okay. Now let us go to let us go to 8.3.2. Reading on A1. 8.3.2. Reading on A1. Okay, so reading on A1 here. So what we can do, okay, we can find the reading on A2. Then we multiply by 2 because they told us it is double. Okay. They say A1 is double A2. So we can find the reading here. Okay. Because we know the resistance and the voltage. Because we know the voltage, we just found it here, is 6. So we can say B, we can use Ohm's law. B equals to I. So we know that we have 6 equals to I multiplied by 10. So then we therefore have I equals to 6 over 10 divided by 10, and then we have 0.6 amperes. 0.6 amperes. And then if we have that, then we can say therefore A1 equals to 2 multiplied by 0.6. Then it's going to be 1.2 amperes. Then 8.3.3. 8.3.3. Yeah, they want the internal resistance, okay? They want the internal. So now, how do we find the internal resistance here? Okay. We know that this is, okay, this is the power source. We have the power source here. Okay. So the resistance which is inside the power source is the internal resistance. Every other resistor is the external resistance. Okay. So now, what are we going to do? We are going to say EMF equals to V external plus V internal. Right? Then E. Now, V external is gonna be, it's made up of what? Made up of, if we look at the circuit, V external is made up of the parallel voltage. This is a parallel connection here because the voltage is the same across the parallel connection. And then it's also made up of there is also a 9 ohm resistor here. Okay, so this is what the resistors that make up the external resistance here. So they make up the external voltage. So we can see that EMF here is made up of the external voltage here is VP plus the 10 amps. Okay, then plus the internal is I multiplied by R. Okay, so this means that the voltage of the parallel connection, the EMF is 20.4. So it's 20.4 equals to voltage of the parallel connection is 9 plus, no, this is voltage of the 9, so not the 10. So we should have 9 even. 9 ohms, not 10. For the 9 ohms, we're going to say I, and then you say multiply by 9 plus the I, which is 1.2 multiplied by R. And then we multiply the 1.2 again. So then we have, therefore, 20.4 equals to 9 plus then 1.2 times 9 and then plus 1.2 R. So it means therefore 20.4 minus 9 minus 1.2 times 9 equals to 1.2 R. Then we can divide by 1.2. So it means therefore 20.4 minus 9 minus 1.2 times 9 and then divided by 1.2 equals to R. Then you use your calculator here. You press all this thing into the calculator. And then you get the value of R here. So it gives me 0.5. So it's 0.5 ohms. Okay. So maybe 0.5 ohms. So yeah. That is the value for R. Now, let us look back, okay? Firstly, they asked us for the definition. And then after that, they said R1. So we had to see where to use the information here. V2 equals to 3V1 because they told us that V2 is 3 times V1. Okay. So again, we substitute I R2, I R1. Okay. Then we know that the two resistors, the resistance is equal here because the currents are equal. So then we simplify. We get R1 equals to 5. And then we can use that R1 to substitute here to get R2. This over here, we say V2 equals to V1 plus V10. Why do we say that? Because they are connected in parallel. Okay? So this is a parallel connection. It's a parallel connection. So those two things are equal because they are connected in parallel. Again, we use that thing. They say V2 is 3 times V1. So we can get voltage across the 10 ohm. So yeah, from there we get the voltage across the 10 ohm resistor. Then from there, if we have that, then we can find the current passing through the 10 ohm. And then we can multiply it by 2 to get the current passing through A1. Okay. Now, let us, so here we used the equation for EMF to get the internal resistance. Okay, that's it. So now, that's it for this question. And so leave your questions in the comments. Right? Leave your questions in the comment and tell me the part that you find useful. Leave your questions there so that I can help you all. So we will do another example next time. Take care.